Guys, welcome to learning microcontrollers. In this lecture, we will be discussing the DC power formula P is equal to VI. Even in the case of AC circuit, this is not much different because you only add the cos theta and the you can say the angle, phase angle. So in our case, it's just a P is equal to VI. So I will try to explain this to you using a simulation as well on the multisim live. So stay tuned. So guys, this over here is our power formula. P is equal to VI. Now first let's understand what it means. So P is equal to power, V is the voltage, I is the current. This formula states that power is directly proportional to the product of voltage and current. So if you multiply the voltage given to the circuit and current taken by the circuit, you get the power. So it means P is proportional to V. This means if power increases, the voltage will also increase. P is proportional to I. So this means that if the power increases, the current will also increase. But the next thing, which is a bit confusing, is that if we do some simple algebra, we come to know that P is equal to V. If I just move the V, I kept the V here, I moved the I there, so I wanted the equation for the V. Now if you take a look here, now it becomes V is equal to P over I. But confusing thing is that it means that this means if voltage increases, the power will also increase. That's good. This means if voltage increases, the current will decrease. Now this is strange because the Ohm law says that V is equal to IR. If the voltage increases, the current must increase. But V is proportional to 1 over I only in case the power is constant. In case of Ohm law, if the resistance is constant, then V is proportional to I. In this case, V is inversely proportional to I, current, only in case the power is held constant. I will show you how. Okay, let's get to our simulator first. Okay, we will be using the multisim live. Just go to your Google, open your Google account and write down multisim live like this first link. Just click on it. I have a lecture on this, how to use this tool. It's a free tool. You just have to get login. Click on login, write the email on which you have signed up. Okay, login, wait. Okay, there we go. Click on create circuit. Okay, let me open the magnifier. Okay, there we go, our simulator. Okay, we will just be making a simple circuit with any load. So for the load, I take a bulb because I can adjust the power. This lamp, I place it here. Okay, the voltage is set to, I double click on it. Okay, the maximum rating is 10 volt. Okay, the power, we will play with this. I make it, okay, it's 10 by default. Burn out voltage 15, no issue. Okay, now since we are doing it for the power, so we are not going to consider the resistor is not required because we are just simulating the circuit. So we take a DC voltage source, that is what we need, and just do the connections. I connect this here like this. From the other side, we connect it to the bottom like this. Okay, now you will also need the ground. So on the left side, on the toolbar, these are the ground. Just connect the ground at the bottom, because in every simulator you need to connect the ground, else there can be a problem in making the circuit. Okay, just connect it from here to here. Okay, there we go. This is our simple circuit. Now we add the meters. Okay, go to the left. Here you have the meters. We will calculate the voltage across the bulb from here to here. Then the next thing is we will also calculate the current. For the current, set any path, all will have the same current. Okay, there we go. Okay, this is our simple circuit. I don't know why it moves to the corner. What is the problem with this? Okay, there we go, our circuit. Okay, the bulb is set to 10 watt rating. You can see that on the right side, the bulb is set to maximum power rated 10 watt and the voltage is maximum 10 volt. So we first run the simulation. Okay, now once I run the simulation, since the DC voltage is 5 volt and the bulb is at 10 volt, the maximum voltage that bulb can have is 10 volt, while the power of the bulb can maximum go to 10 watt. See this power, We can change the voltage, but this cannot be changed. This is the power of the bulb. It is constant. So now take a look here. Right now, when our bulb is when our applied voltage is at 5 volt, the current is at 500 milliampere. Now if I do some math, I open the calculator. As per our formula, P is equal to VI. So we have the voltage input at 5 volt, P is equal to V, 5 volt, 5 multiplied by the current is 0.5. We are giving a power of 2.5 volt to this bulb. So that's why it's not that bright. You can see that it's not bright at all. Why? Because the power is not maximum. We need 10 watt to make it go full bright. Now what I do is that I increase the voltage from here. Okay, we increase the voltage and see what happens. See, as soon as I start increasing the voltage, the current starts to increase. Also the voltage starts to increase. Here we are following the Ohm's law. V is equal to IR. Voltage is increasing with the current. See, there we go, the Ohm's law. Now this is why both the laws work together. Now this is the Ohm law. Voltage also increases, the current also increases. But what happens as soon as we reach the maximum power? Now take a look here. Okay, there we go. Now at 10 volt, the current is 1 ampere. Why 1 ampere? The current is a drawn quantity. It can be 2, 3, 4, 5, 6 ampere. Why 1 ampere? Why? Because the voltage, the power is fixed. It's constant. It cannot be changed. Our voltage and current will adjust itself in proportion. Now take a look here. What I do is that I stop the simulation. I go to the bulb setting and instead of 10 watt, I make it 30. Here you go. Now I click on run. The current automatically becomes 3. Why 3? Because remember, the power is constant. Now the power is 30 watt. We cannot decide the current. Current is drawn by the quantity. To achieve the maximum power at the maximum voltage, it will automatically adjust to that by varying either the current or the voltage. That is why it's inversely proportional. Voltage is inversely proportional to the current in case your power is constant. Now take a look here. I set the power of the bulb to 15 watt. Now the current will automatically adjust itself. See, it's now 1.5 ampere. I didn't change the voltage, it's fixed. I didn't change anything. I just readjusted the power because power is constant. In case your power is constant, either the current or the voltage will adjust to cater for that power, and it is always the current mostly because it is a drawn quantity. Voltage is whatever we give. If we give some voltage, then the current will automatically adjust itself. So because of this reason, we can say that voltage is inversely proportional to current in case your power is constant. But remember that power must be constant. If power is constant, then your voltage is inversely proportional to current. So this verifies our P is equal to VI equation, that power is directly proportional to voltage and current. So guys, I hope you guys learned something from this video. If you guys have any questions, please do ask. We'll see you in the next lecture. Goodbye until then.